Good morning, everyone. Yes. So, good morning, all of you. Hope you're doing good. Actually, there was some technical issue came up, so that's the reason why I was solving those. So that's why I'm late. Yeah. So very good morning to all of you. Now let's come to the session. Actually, yesterday also we have lost our session due to the power issues. Now, so we have been discussed about the GVF, gradually varied flow, and whatever the type of profiles and length of the GVF. Now let's see the next topic, hydraulic jump. The next topic is a hydraulic jump. Okay. So what is this hydraulic jump, sir, and how it is going to be happen, and what is the purpose of this hydraulic jump, and how we are going to do analysis of this hydraulic jump. So let's see. First of all, what is the name means? What is hydraulic jump? Is it a steady flow or unsteady flow, my dear? Does hydraulic jump is a steady flow or unsteady flow? It is a steady flow. And is it a uniform flow or non-uniform flow? Is it a uniform flow or non-uniform flow? It's a non-uniform flow. And is it a gradually varied flow or rapidly varied flow? A rapidly varied flow. So you know that the hydraulic jump is a steady, non-uniform, rapidly varied flow. And now, how it is going to be created, and is it an advantage to us or disadvantage to us? And what we are going to do? It is a, I can write a point over here. Yes. It is a steady, non-uniform, rapidly varied flow. It is a steady, non-uniform, rapidly varied flow. When it is going to be happen? Whenever the supercritical flow meets the subcritical flow, then only it is going to be happen. Or whenever the flow below CDL tries to meet the flow above CDL, then it is going to be the hydraulic jump. Okay. Forms when supercritical flow meets subcritical flow. When the supercritical flow meets the subcritical flow. Okay. So now, what is the meaning of that one is, if this is a, if this is a hydraulic, means if this is a spillway hydraulic structure, and you know that in the previous, does the screen is not visible to you? Does the screen is not visible? Tell me please. It's visible, all clear. So Mr. Ganesh, you please check off your internet. Now, you know this is a channel bed. Okay, fine. So now I'm going to ask you one question. The question is, listen to me and tell me carefully. See, while I was discussing about the mild slope and steep slope in the GVF, on the downstream side, hydraulic jump occurs in what type of slope? Lesser slopes or more slope? Lesser slope or more slope? Remember and tell me. So, does hydraulic jump occurs on the mild slopes or steep slopes? Mild slopes. Because if you go back here, I'm mentioning you. Yes. You see here in the M3 profile, in the case of the M3 profile, so this is mild slope, right? As it is in an M3 profile. So here the flow should meet from super to subcritical. There is a hydraulic jump. Yes or no? But if you look over the S3, if you look over the S3, is there any hydraulic jump? No. So on the downstream side of a hydraulic structure, the hydraulic jump occurs if it is a mild slope or steep slope. Mild slope. Okay. So generally we prefer lesser slopes on the downstream side. Generally we prefer lesser slopes on the downstream side. Okay. So now we are going to prefer the mild or flat slopes on the downstream side. You know, this is the water level on the upstream. So, and from here, if I open the gate, then whatever the water falls, and this is nothing but the nepe, and once it falls, then it is going to be moves, means this is vena contracta, minimum cross section or not. It is going to be form a minimum cross section, vena contracta, and then water level is going to be rises, forms a third profile, yes or no, and somewhere, you know, somewhere there must be CDL, and below CDL supercritical flow. Somewhere there must be CDL. So that's going to be the supercritical flow. And now you see this is going to be asymptotical to, sorry, perpendicular to the CDL. So the flow will meet perpendicular to the CDL, and it has to meet NDL or not. Then the hydraulic jump is going to be created. So now you tell me when the hydraulic jump is going to be created. So this is nothing but reverse of flow or not. Now this water level is going to be rises, and again it is going to be uniform. Okay. So now you tell me while it is rising, see this is nothing but a third profile, yes or no? And then there is a hydraulic jump when the flow from the supercritical meets the subcritical. Flow from the supercritical meets the subcritical. Okay. Now, while doing so, this is going to be cause a reverse flow or not? Yes or no? While rising the jump, it is going to be cause a reverse flow, and due to this reverse flow, lot of eddies are going to be created. And that eddy losses are very, very significant. So while during the flow, while doing so, means it is going to be rises from subcritical super to subcritical. While doing so, lot of due to reverse of flows, eddy losses are going to be present, and that eddy losses are significant, and it dissipates the energy. So what is the meaning of that concept? If I take the channel bed as horizontal, means I am taking the channel bed as a horizontal. Okay. And you see up to this point there is no loss, right? And the loss is going to be happen in this zone only. Okay. And you know whatever this depth, whatever this depth, and this depth is known as let's take it as y1, sorry, y, and before the jump, whatever the depth, let's take it as y1, okay. After the jump, whatever the depth, let's take it as y2 is going to be serial line. So now you see this is y, and here it is going to be y1. This is y, and he is going to be y1. So initially there is no head loss, yes or no? So from here to here, the energy is going to be same. You know that this is nothing but the total energy line. Okay, whatever this is going to be the total energy line. Yeah. So whatever here it is going to be the total energy line now. Okay. Up to this point, the total energy is going to be same, my dear. Up to this point, the total energy is going to be same. Okay. So in this zone, this is going to be the velocity head, and here this is going to be the velocity head. Okay. So now this y and y1, if you observe here, the specific energies are same. Here the specific energies are same. So if I take this as a y, if I take this as a y, and what about this value v1 square by 2g? So this specific energy, let's take this value of a specific energy, and whatever the specific energy at this zone, both are same. Both are same. So E1 and here also E1. Okay. So E1, E and E1 both are same. E and E1 both are same. Okay. Now you see, while doing so, what I'm saying is while doing so, due to reverse of flows, eddy losses are creates and dissipates the energy. While doing so, now you see, while doing so, due to reverse of flow, the eddy losses are going to be creates and dissipates the energy. Now from here onwards to here onwards, due to eddy losses, the energy will decrease on that. The energy will decrease, and once the jump is going to be formed, now see up to this point the jump, right? And once the jump forms, again it is going to be the normal one. Again it is going to be the normal one. I hope you understood here. So now you see clearly what I am saying is, up to this point, have I changed the total energy line? No. But if you observe in this zone, I am representing you whatever this is nothing but energy loss. Whatever it is nothing but the energy loss. So what is this? Energy loss. And dissipates the energy, which means delta E. And results in water, results in the depth of flow after hydraulic jump falls below the alternate depth of pre-jump depth. Pre-jump depth. So the depth of flow after the hydraulic jump falls below the, means falls short of, I can say, falls short of alternate depth of the pre-jump depth. See, you see this figure, my dear. If you see this figure, first of all, you look over this portion, E and E1. You know E is equals to E1, which means Y and Y1 are alternate depths. Have you remembered that? Yes or no? I have shown you these examples in the alternate depths also. So whatever the alternate depths over here, E and E1 are going to be the same specific energy. So Y is an alternate depth of the Y1. Y is an alternate depth of the Y1, where Y1 is a pre-jump depth. So before the jump, whatever the depth, this is nothing but hydraulic jump or not, okay? And where Y2 is post-jump depth. Where Y2 is post-jump depth. and y is nothing but an alternate depth of the pre-jump depth or not. So whatever the depth of flow after hydraulic jump, which is nothing but y2, falls short of the alternate depth of the pre-jump depth. So what is the pre-jump depth? Y1. What is the alternate depth of that one? Y. So you know that this y is y2 is less than y, and this is nothing but alternate depth of y1. Alternate depth of y1. So now what I want to say here is, up to the jump there is no head loss, and we are going to assume the loss is going to be due to friction, and frictional losses are very less. Frictional losses are very less. So now here I hope you understood the meaning of the hydraulic jump and what is happening while doing so. Due to reverse of flow, eddy losses are going to be created and dissipates the energy, results in the depth of flow after hydraulic jump falls short of the alternate depth of the pre-jump depth. So now, so what is eddy loss? Eddy loss means due to the reverse of flow motion, what happens is there itself, the energy of the water is going to be dissipates. The water is moving and again it is hitting back. Water is moving and again it is going to be hitting back. So especially you can see this in the case of the corners also, eddy losses would be there. So this is one form of the loss, my dear. This is not a frictional loss. The eddy loss are going to be different. Okay. So now the note point is effect of eddy losses are significant than frictional losses. Effect of eddy losses are significant than the frictional losses. Now, whenever the losses are going to be more, see, if the loss is going to be, now what I'm going to say one point, see, when the losses are going to be less, then you go for the energy equation. And when the losses are going to be too high or significant, we are going to analyze by means of linear momentum principle. Linear momentum principle. Keep that in your mind. So now what we are going to do is a hydraulic jump is analyzed by linear momentum principle. Sir, why you are using the linear momentum principle, sir? Whenever the losses are going to be the eddy losses, then we analyze the hydraulic jump by linear momentum principle. Okay. Now, where y1 and y2 are there, right? So what is y1? Pre-jump depth. What is y2? Post-jump depth. Keep that in your mind, that the post-jump depth is less than the y, which is an alternate depth of y1, which is an alternate depth of y1. Okay. So now let's see the analysis of the hydraulic jump. Let's come to analysis of hydraulic jump. So now, again, when we are going to analyze them, we are going to have some assumptions are not. The common assumptions are, number one, flow is steady. The common assumptions are, number one, flow is steady and pressure distribution is hydrostatic. So, and pressure distribution is going to be hydrostatic. Okay. So flow is steady and pressure distribution is going to be hydrostatic. Okay, now next point number 2. See, as we are discussing about all these flows, now let's see the second thing is as a channel bed slope is going to be as channel bed slope is very less. Assume it as a horizontal. Assume it as horizontal. So when you assume it as a horizontal, then the driving force Fd is equals to 0. The driving force Fd is equals to 0. Keep that in your mind. So as a channel bed is going to be horizontal, means that the driving force is going to be 0. And now you see that jump is going to be happen over a shorter span or not? The jump is going to be happen over a shorter span. See, you know the frictional losses are due to the boundary. Yes or no? As the jump is happening over a shorter span, as the jump is happening over a shorter span, keep that in your mind. As the jump is happening over a shorter span, then what I am going to say is neglect the frictional losses. Over short span, frictional losses can be neglected. Can be neglected. So when the frictional losses are going to be neglected, then resisting force is equals to 0. So these are the basic assumptions for the analysis of the hydraulic jump. So which principle is going to be used? Linear momentum principle. Now, so y2 is less than y1 now. Who said that y2 is greater than less than y1? So false short of means y2 is not equals to y. If there is no energy loss, see from this point to here, there is no loss. As there is no loss, then y and y1 are alternatives. And if there is no loss further rises, then y2 and y should be same, right? But due to these losses, the flow loses some of the energy, so the depth falls short of it. Okay. Now let's come to the analysis. So as I'm going to do the analysis here, let's see. This is a channel bed. Let's see. There is a hydraulic jump. Okay. Now you see, this is the pre-jump depth y1, and this is the post-jump depth y2. Is a pre-jump depth y1, and here is a post-jump depth y2. Okay, and you can observe that whatever the total energy up to this point, so this is a total energy line, and from here onwards, once the hydraulic jump is going to be formed, due to this jump, then what is going to be happen is the total energy will decrease, and up to the jump. After the jump, the total energy line is going to be remain same. Now, whatever this difference, right? This is known as energy loss. This is known as energy loss, where delta E is energy loss. And this energy loss is due to whom? Eddies, not the friction. This energy loss is due to whom? Eddies, not the friction. Okay, where Y1 and Y2 are known as conjugate depths or sequent depths. Where Y1 and Y2 are known as conjugate or sequent depths. See, I told you why. In the case of the same specific energy, I told you this is nothing but the alternate depths. Yes or no? Now, Y1 is pre-jump depth, Y2 is a post-jump depth, where we can say that Y1 and Y2 are conjugate or sequent depths. Now, let's see. Let's apply the conditions. Flow is steady and pressure distribution is hydrostatic. That's what I said. The pressure distribution is hydrostatic means you know it clearly. The meaning of pressure distribution hydrostatic. So whatever this is nothing but the hydrostatic pressure. Whatever this is nothing but the hydrostatic pressure. Yes or no? So this hydrostatic pressure, what is this value? Gamma W into Y1. And due to this hydrostatic force FH1. Similarly, on the downstream side, you know the meaning of hydrostatic pressure on both the sides of this element. This is gamma W into Y2. Whatever the force acting over here, this is FH2. I hope you remember in the case of the uniform flow, I have been discussed these things. Yes or no? Then apart from that, inside of that fluid, so you can observe there is a driving force Fd and there is a resisting force Fr. There is a driving force Fd and there is a resisting force Fr. And whatever you see, you observe the difference between these two is there or not? This is a jump. Whatever this difference is known as Hj. What is this? Hj. And from here, this length is known as Lj. So what is this Hj, sir? The Hj is going to be the height of jump. What is Hj? Height of jump, which is going to be y2 minus y1. And what is Lj, sir? Length of jump. In other words, represent here. Length of jump. Definitely, Mr. Chilipireddy Karthireddy, wait for movement, Nana. So why you are taking definition of the means what is the definition of conjugate depths? Wait for that, I will tell you now. So as there is a zero driving force, then how will flow occur, sir? That's what the point over here. That's what the point over here. There is a hydrostatic forces are there, and in between, due to the eddy losses, due to the eddy losses, that's reverse flow is the main cause. Okay. So now coming to the energy loss. Give me a minute, please. Okay. So now, once we know this, they are going to be the where Hj is height of jump, which is nothing but y2 minus y1, which is nothing but y2 minus y1, and Lj is length of jump, and this Lj is approximately is equals to 6.1 times of height of jump. 6.1 times of the height of jump. Okay. So now, my dear, when the hydraulic jump is going to be happen, keep that in your mind. When the hydraulic jump is going to be happen, whatever the height of the jump, that depends upon the difference between the y1 and y2, and the length of the jump depends upon the height of jump, which in turn depends upon y1 and y2. So we need to analyze this y1 and y2, and why I am calling this one as conjugate or sequent depths. Wait for a moment, I am going to say that. Wait for a moment, I am going to discuss that. Now, apply the linear momentum principle. Apply linear momentum principle. When you apply the linear momentum principle, what happens? Well, see, this is the combination. Now, what is the linear momentum principle? What is the linear momentum principle? I told you this one. Net force acting along direction of flow is nothing but rate of change of momentum. Okay. So what are the forces, net forces acting over here? Tell me. So if you see there you can say the forces as can I say like FH1 now plus FD plus FD plus FD minus FR minus FH2 is equals to rate of change of momentum means rho Q into V2 minus V1. Rho Q into V2 minus V1. If you have any doubt, you go back there in uniform flow. I mentioned how this rho Q also came. Now apply the conditions. What is the conditions? As channel bed is slope is very less, assume it as a horizontal. Assume it as a horizontal means now I can say the driving force is going to be 0. As jump occurs over shorter span, frictional losses can be neglected. Fr is equals to 0. Fr is equals to 0. And what is remaining? The remaining is nothing but hydrostatic force. The remaining is nothing but hydrostatic force. So, the hydrostatic force, you know that Fh is a hydrostatic force. And that hydrostatic force, Fh is equals to gamma W into A into Z bar. Gamma W into A into Z bar. So gamma W into A into Z bar, where Z bar is a centroid from water surface. Centroid from the water surface. So what is this gamma W into A into Z bar, sir? Or we can call it as a Y bar also. We can call this as a Y bar also. So now you see. So gamma W, what is the hydrostatic force? Gamma W into A into Z. Now, what is the centroid from the free water surface? You please keep that aside. That I will discuss you later. So, what is this hydrostatic force, sir? Hydrostatic force means gamma W, means generally the area of the pressure distribution. The area of the pressure distribution, we take it as the area of the pressure distribution is nothing but the hydrostatic force. So now here I am taking this gamma W Y1 and gamma W Y2. Wait for that moment. This is a normal definition, gamma W into A into Z bar. So for the rectangle and for triangle, how it is going to be there? Wait for that moment. Okay. Now you please substitute over here. Now if I do substitute gamma W into A1 Z1 bar minus gamma W into A2 Z2 bar. So can I write this rho Q into V as a Q by A2 minus Q by A1? Yes. I can write like this because the velocity is nothing but discharge by area. Okay. Now, you know that gamma W is nothing but rho into G. Gamma W is nothing but rho into G. Yes or no? Gamma W, unit weight is nothing but density into gravity. So now, if I substitute that gamma W as a rho into G, if I substitute that gamma W as rho into G, rho is equals to gamma W by G. Rho is equals to gamma W by G. Gamma W will get cancelled. So I can directly write this as gamma W by G. So gamma W will get cancelled. Then A1 Z1 bar minus A2 Z2 bar is equals to Q square by GA2 minus Q square by GA1. Q square by GA2 minus Q square by GA1. Yes or no? Q by G gets inside, Q square by GA2 minus Q square by GA1. Okay. Now let's take the one terms on one side. Then finally Q square by GA1 plus A1 Z1 bar is equals to Q square by GA2 plus A2 Z2 R. Q square by GA1 plus A1 Z1 bar is equals to Q square by GA2 plus A2 Z2 bar. A2 Z2 bar. So keep that in your mind. Now, whatever this is nothing but see now after applying the linear momentum principle, I am dealing with the forces or not? Think I am asking you. Am I dealing with the forces or energies? I am dealing with the forces. Am I dealing with the forces or energies? Forces. Which means at the end from here to here. So if you see the figure, whatever the net force at 1, whatever the net force at 1 and whatever the net force at 2, both are same or not? Whatever the net force at 1 and whatever the net force at 2, both are same, which means this entire is going to be one force. And let me take that force as a F1. Let me take that force as a F1. So now, so whatever the total force I am taking, why did you take the moment of forces? And it's not a moment of force, right? That's force. What are you talking? Can you please explain the rate of change of momentum? No, I don't explain because I have explained n number of times. If you want, you can go to the previous notes. There I explained this point clearly and I told you what is the one term by term I said over there. So now this entire is nothing but, can I say this as a one force F1 is equals to F2, where F is known as a specific force, where F is known as specific force. So what is the meaning of this one? After all this, I am taking the forces, and once I take the force, at the end, the section 1, whatever the net force on the section 1 is a net force on the section 2. Net force on the section 1 is a net force on the section 2. So what is this specific force? Q square by GA plus A into Z bar. Q square by GA plus A into Z bar. And where this Q square by GA is nothing but momentum flux per unit weight. Per unit weight. So what is the meaning of momentum flux? You know that rate of momentum momentum flux. Rate of momentum or momentum flux is nothing but capital M. Yes or no? So capital M is nothing but M into V by T. Capital M is nothing but M into V by T. And from this only I got to know rho QV. Yes, this is a rate of momentum flux. Now, what is the momentum flux per unit weight, sir? Now, per unit weight. So now divide with per unit weight. Divide with per unit weight. Now, what is the unit weight, sir? The unit weight can I say it as a rho into G? The unit weight can I say it as a rho into G? Then rho will get cancelled, and now I can write Q into velocity, right? What is this V? This is not volume, velocity. And can I write this velocity as Q by A? Yes. So now finally what is this value? Q square by GA. So what is this? This is momentum flux per unit weight. The momentum flux per unit weight. This is nothing but rho QV, my dear. So what is rate of momentum or momentum flux? M. And what is capital M? Small m into V, which is nothing but momentum per unit time. Momentum means mass into velocity. And mass into velocity by time means rate of momentum or momentum flux. And similarly, whatever this is nothing but, this is a hydrostatic force force per unit weight. Hydrostatic force per unit weight. Okay. So now to tell me what is the specific force. See, what I want to say is so if bed is horizontal, then why there is a hydraulic jump? Is this a question you want to ask me? Seriously? I have been discussed about in GVF, and I have been discussed there whenever there's a bottom, bed is going to be the milder to milder and milder, then due to the imparting of the energy, the hydraulic jump is going to be created. So if we use rather than H2O, we must take the density of the fluid, right? No, we don't use any other kerosene into the flow of a channel. Do we allow the flow of kerosene or any other fluid into the channel? No, we do discuss about the water only. So don't worry about that. Okay. So now hydrostatic force per unit weight. So now see, observe here carefully. At the end of all this discussion, see, I am discussing about the forces. What are the forces are there? Hydrostatic force is there, driving force is there, resisting force is there. And I have removed the driving force and resisting force. Okay. And now, whatever due to this hydraulic jump, there must be some momentum change or not. Due to the eddy losses, momentum change will occur. Yes or no? And that momentum change is going to be cause the momentum flux per unit weight. So now, the definition of a specific force is specific force is the total force per unit weight. Specific force is the total force per the unit weight. I hope you remember the specific energy. What is a specific energy? Specific energy means total force, total energy per unit weight by taking the channel bottom as a datum. Yes or no? Have you remember in the case of the specific energy also, what is the common assumption I made? The common assumption I made in the case of specific energy is channel bottom is going to be horizontal and frictional losses are going to be negligible. The common assumptions in the hydraulic jump, in the specific energy is also channel bottom is horizontal and the channel bed slope is very less. Channel bottom is horizontal and frictionless. Here also I'm taking the same thing, right? So at the end, what I got to know is this is nothing but the specific force. Okay. What is this? We have not taken Z in the uniform flow. Don't interpret the concept of yourself. Okay. Some of our student is asking, sir, net force is towards upstream, so flow occurs in backward direction. What is the meaning of backward direction? And remember, that's a reverse of flow. In this zone only, that reverse of flow would be happen. Okay. And that doesn't cause the flow to be moved towards the upstream side. First of all, you try to listen once. You focus on the listening rather than the questioning. So then, what is a specific force? A specific force is the total force per unit weight. Total force per unit weight. Now, from the specific force only, I am going to call the conjugate depths. Now, you tell me why I am going to call the y1 and y2 are conjugate depths is y1 and y2 are the conjugate depths because y1 and y2 are the depths corresponding to the same specific force. Yes or no? So before the jump and after the jump, the specific force is same. So the depths corresponding to the same specific force is known as a conjugate or alternate depths now. So I have got this equation, and this is the equation which is going to be used for the analysis of the hydraulic jump. And from this, what I'm going to do is I am going to derive the specific force curve. See, this is not a moment of the hydrostatic force. Please keep that in your mind. This is not a moment of the hydrostatic force. See, for rectangle, okay, a lot of students are asking me, look, what is the hydrostatic force? Gamma W into A into Z bar. Okay, for rectangle, you see, this is the water level. Centroid is just below the free water surface. What is centroid? Centroid is nothing but y by 2 because he is a rectangle. Yes or no? And hydrostatic force gamma W into area. See, area we don't know, B into 1, y into 1 into y by 2. What is this value? Half gamma W y square. What is the hydrostatic force? Half gamma W y square. Yes or no? Now you tell me, what is the area of the pressure distribution? See, generally we take the width is going to be 1 r per unit width, my dear. So we are going to take the analysis everything per unit width. Keep that in your mind. We are going to take analysis for everything for the unit width. Yes or no? Then what is the area of this pressure distribution? Half into base. What is base? Gamma W into y into height. What is height? Y. Half into base into height. Gamma W into y1 into y by 2. Gamma W y square by 2 r naught. And what I got here? Gamma W y square by 2 only. This is the actual form. This is the actual form. So generally we don't use this one. Directly we see the pressure distribution. Directly we see the pressure distribution and we say, so gamma W into y square by 2. Okay. But as we know, we have different type of channels. That's the reason why I'm taking this one. Specific force curve. You see, specific force curve. We call it as a F curve. Or we call it as F curve, specific force curve. So for that, this F is equals to Q square by GA plus A into Z bar. So now I'll split this further again. Let's take F1 as Q square by GA. Q square by GA. So now if I draw the variation of the specific force with respect to depth, I hope you remember the specific energy. How I have on the specific energy? V square by 2G plus Y, right? I split this and I split this and I have drawn the graphs initially and then I draw the specific energy curve. Yes or no? But this is a specific force curve So in the case of the specific force curve, now the F is inversely proportional to A or directly proportional to A. You see, if I take rectangle, my dear, then area is equals to B into Y. If I take rectangle, then area is equals to B into Y. Yes or no? And if I take triangle, then area is equals to my square. If I take triangle, then area is equals to my square. See here, F is inversely proportional to A, not with respect to the depth directly. Yes or no? So now, what I am going to do is, here F is inversely proportional to A. If here F is inversely proportional to A, which means the curve is going to be falling. While it is falling, it is going to be like this. And this curve represents momentum flux per unit weight. This curve represents momentum flux per unit weight. Similarly, F is equals to A into Z bar. Area is a function of Y and Z is also a function of Y. Area is a function of Y and Z is also, see, don't ask me why I am drawing the falling curve, sir, because F is inversely proportional to A. And here F is directly proportional to A and Z bar is a function of whom? Y by 2. Means Z bar is a function of Y. So F is directly proportional to A into Z bar, which means F directly proportional to Y. So for F is equals to A into Z bar. On x-axis, this is F, and y-axis, this is Y. So now this is going to be here as F is equals to A into Z bar, which means directly proportional. So directly proportional means the graph is going to be rising. The graph is going to be rising. So the graph rises like this. The graph is going to be rises like this. And whatever, this is nothing but hydrostatic force per unit weight variation. Now I need to find out whom? I need to find out Q square by GA plus AZ bar. So then there comes the F curve. F curve. Now, if you club these two, then what is going to be happen over here is on x-axis Y, on y-axis F, on y-axis is going to be F. So now one is falling, other one is going to be rising. One is falling, other one is going to be rising. So now if I join both, the curve is going to be looks like C shape. The curve is going to be looks like a C shape. Sir, why it is going to be looks like a C shape, sir? Now you see, sir, see, in the case of the momentum flux, at lesser depth, the momentum flux is more and the hydrostatic force is less. Lesser depth, momentum flux is more. See, this portion represents Q square by GA plus A into Z bar. Q square by GA plus A into Z bar. Keep that in your mind. So if I join these two, the two graphs, if you combine hydrostatic force and momentum flux, now the shape of the graph is going to be a C shape. So this is known as a specific force curve. What is this? Specific force curve. So if force directly proportional to area means linear variation. Very good question, my dear. That is for rectangle. What about for the triangle? What is the area for the triangle? What is the area for the triangle? M by square. What is the area for the trapezoidal? Some other area. So here I am not mentioning you Y directly. Did I? I am not mentioning you Y directly. I am mentioning you A. So if I mention with respect to A, then the variation is going to be parabolic. Now, This curve is known as a F curve. This curve is known as F curve. Whatever this is known as a F curve. F curve. So similar to the E curve, please try to recall the E curve. Similar to the E curve. See this F curve, why I take the discharge as constant? Yes, sir. When I take the discharge as constant, then I can say F is inversely proportional to E. So can I say the F curve represents the variation of F versus Y for a given discharge? Point number one. Points. F curve represents variation of F and Y for a given discharge Q. For a given discharge Q. Next, point number two. Point number two. Now you see, out of all this, this curve has some minimum force on that. That is going to be F minimum. And whatever the depth corresponding to the F minimum, this is known as a critical depth. Whatever the depth corresponding to minimum, that is going to be the critical depth. So how we got to know this for F minimum, that is going to be critical flow, sir? I hope you remember the E minimum, right? There I told you, see, for F to be F minimum, then you simply differentiate the force with respect to Y is equals to 0. If you differentiate the force with respect to Y is going to be 0, again you are going to end up with the Q square by G is equals to A cube by T, which is critical flow condition. Which is a critical flow condition. So if you differentiate the force with respect to the depth, dF by dy is equals to 0. See, I am not going to do the derivation because I have given this type of derivation for the E is equals to E minimum. So when you differentiate E is equals to E minimum, means dE by dy is equals to 0, you end up with this condition only, and this condition is known as a critical flow condition. Yes or no? So point number two. Now, critical flow occurs at a minimum specific force. Critical flow occurs at a minimum specific force. Critical flow occurs at minimum at F minimum, and depth corresponding to it is critical depth, YC. So once we know the YC, then above this is going to be subcritical, and below here it is going to be the supercritical. Sir, critical depth given by F curve, will it be equal to the critical depth given by E curve? Yes, until for a given discharge. For a given discharge, okay, for a given discharge. You keep that in your mind. The discharge should be constant. Then whatever the YC I get from the E curve and the Y curve, both are, means E curve and F curve, both are same. Now, you see, for any specific force, next point, for any specific force other than F minimum, if I drop a line, for any specific force other than F minimum, there exists two depths. There exists two depths. One is a supercritical flow depth. Let's take it as Y1. Let's take it as a Y1. And other one is going to be Y2. It's going to be subcritical depth. See, in the case of the specific energy, I told you, for any specific energy other than E minimum. For any specific energy other than E minimum, I told you there exist two depths known as alternate depths. Yes or no? Now, for any specific energy other than F minimum, which means for the same specific energy other than F minimum, there exist two depths now, and those depths are known as a conjugate depths or sequent depths. Now, final point is for any specific energy other than E for any specific force other than F minimum, there exists two depths known as conjugate or sequent depths. So that's about the specific force. And from this specific force, now I can say the node point as the node point is specific force before and after jump is same, which means F1 is equals to F2. So when the specific forces are same, that's what I said, right? What is this here? Whatever the specific force before the jump and after the jump, both are same. And now just now, for any specific force other than F minimum, there exists two depths. As the same specific force, then the depths are going to be the conjugate, and so Y1 and Y2 are known as conjugate depths. Okay, that is the reason why I said the pre-jump depth and post-jump depth as a conjugate depth. One of the person has asked me, sir, why you are taking as a conjugate depths? Why I have taken as conjugate depths is those are the depths corresponding to the same specific force. Those are the depths corresponding to the same specific force. Okay. So I hope you understood the specific force concept and specific force curve. Just a replica to the specific energy curve, but there we discuss about energies. Here we are discussing about the forces. Yes, sir, that means that at a minimum specific energy, we have minimum specific force also. Yes, my dear. For the same discharge, keep that in your mind. Discharge should be constant. For the same flow rate, whether when the specific force is minimum and when the specific energy is going to be minimum, there the critical flow is going to be happen. Okay. Sir, can we take F minimum as E minimum? Arre Baba, F minimum cannot be E minimum. F is force, E is energy. How come you equate both? But at those conditions, the depths are going to be same. Y is equals to YC. Okay. So now, is there any relation between specific force and discharge? If we have, what I mean? Sir, how come we measure the pre-jump and post-jump depth practically? No, that's what we are going to measure. That's what we are going to know. We are going to know. That's what we are going to know here as If I know one depth, then I have to find out the other depth. Okay, now let's see the analysis further analysis. Now let's see the further analysis. I hope you understood this. Now, based upon this, look, let's go back once again. See, what is the practical applications of the hydraulic jump? Applications of the hydraulic jump. The applications of the hydraulic jump is, so the application of the hydraulic jump is to dissipate the energy Why, sir? Why should I have to dissipate the energy? Number one means, why should I need to reduce the energy? See, if you don't reduce the energy, whatever this flow over here, this is a supercritical flow. Yes or no? If you don't reduce the energy, the supercritical flow means a shooting flow. And due to that shooting flow, what happens is that the downstream bit will get collapsed. So, but when you rise this hydraulic jump, what is going to be, means when you are going to prepare the hydraulic jump, which means hydraulic jump is our concern. We are going to make sure to create the hydraulic jump. So when I create the hydraulic jump, what happens is, then the flow is going to be converted from super to subcritical, and moreover that due to this reverse flow, some portion of the energy will decrease. As some portion of the energy will decrease, then what happens is the net energy in the flow will less, and as the flow is subcritical, it won't cause much effect to the downstream bed. So number one is to dissipate the energy, and number two is to intermix chemicals for treatment of water, for water treatment. So intermixing of chemicals for water treatment. So what is the meaning of this one, sir? See, in order to treat the water, that huge volume of water, you cannot directly add the chemicals into the water. But once you create the hydraulic jump, no? So in the hydraulic jump, when you insert the chemicals, means when you are going to introduce the chemicals into the hydraulic jump, then due to this reverse flow, what happens is that the chemicals will be fully dispersed into the water, and it will start treats the water. Okay, so that's nothing but water treatment that you are going to see in the wastewater engineering. Means in environmental engineering, at the end, while you are going to dispose the waste on the river, then you have to treat the water. So now our concern here is to dissipate this energy, which means the energy loss. So I need to find out that how much energy loss is going to be happen. Okay, so now if that is the case, let's see how to determine the energy losses. Okay, now relation between conjugate depth and YC. And before going to that, I can say one more point over here. Critical flow occurs when Froude number is equals to 1. B, if E becomes E minimum, also critical flow is going to be happen. C, if F becomes F minimum, also Froude number is going to be happen. D, Q is equals to Q maximum also, then flow number is going to be, means the critical flow is going to be happen. So if I give you as a MSQ, there is an MSQ. If I give you as an MSQ, the answers are going to be everything. The answers are going to be everything. So here, when flow number is equals to 1, and E becomes E minimum for a given discharge, F is equals to F minimum for a given discharge, Q is equals to Q maximum for given S and means specific energy and a specific force. Keep that in your mind. In all these conditions, whenever you see this condition, then you can say, if I say Froude number is 1, then there the energy is minimum, force is minimum, discharge is maximum. If I say discharge is maximum, energy is minimum, force is minimum, Froude number is equals to 1. So critical flow occurs in all the cases, and in all the cases the depths are going to be same. Keep that in your mind. So now relation between the conjugate depths and critical depth. Okay. So now what is this relation, sir? Just now we said that whenever I say mention the conjugate depths, I hope you remember how I got the relation between the specific energies. Let me recall. Yes. So relation between the alternate depths and critical depth. Here the energy is going to be same. Now there I want the relation between the conjugate depths and YC. Now I want the conjugate depths and YC. What is conjugate depths? The same specific force, which means Q squared by GA1 plus A1 Z bar is equals to Q squared by GA2 plus A2 Z2 bar. Okay, where Z bar for rectangle, in the case of rectangle, this is channel flow, and you know, in the case of the rectangle, the Z bar is simply y by 2, and if it is a triangle, the center of the triangle from the free water surface, the Z bar is equals to y by 3. So Z bar is nothing but y by 3, and if it is a trapezoidal, then you know you have to find out. If it is a trapezoidal, because people may ask, if I say rectangle and triangular, some of the people would be ready to ask, what about the trapezoidal, sir? If you take for the trapezoidal, from the free water surface, this is A and this is B, and he is going to depth of 1. So now what is centered over here is y by 3 into b plus 2a by b plus a. See here you need to know the base width and top width. So y b plus 2a by b plus a. So now that's it for the trapezoidal. That's a centroid, right? From here to here, this is a centroid. Now let me take for rectangle only. Now I am doing for the analysis of rectangle, my dear. In the case of the rectangle, there also, if you see, there also I mentioned for the rectangle only, Q square by G A1. You know that in the case of the rectangle, first let me write down those values. In the case of the rectangle, area is nothing but by, Z bar is nothing but y by 2. Okay. Now Q square by G A1 means B into Y1 plus A B Y1 into Z bar Y1 by 2 is equals to Q square by G A2 B Y2. See, I am not reducing any width over here. by2 into y2 plus y2 by 2. Okay. Now you see this b divide with b on both sides. Sorry, multiply with b on the divide with b on the both sides. If you divide with b on both sides, divide with b on both sides. See, this derivation is very, very important because I am deriving for the rectangle, and if they ask, you have to do it for the triangle also. Okay. So now you see, in the case of the rectangle, capital small q is nothing but capital Q by B. Small q is nothing but capital Q by B. Okay. Q square, if you divide with B on the both sides, then what is going to be happen? Q square by B square. Yes or no? Q square by B square means small q square by G y1 plus B will get cancelled. Y1 square by 2 is equals to Q square by G y2 plus y2 square by 2. Q square by gy1 plus y1 square by 2 is equals to q square by gy2 plus y2 square by 2. Now, you take q square by g is one side, 1 by y1 minus 1 by y2 is equals to 1 by 2 into y2 square minus y1 square. Okay. So now, see further. Q square by g into y2 minus y1 by y1 y2 is equals to y2 square minus y1 square by 2. See, you know that y2 square minus y1 square is nothing but y2 minus y1 into y2 plus y1. So y2 minus y1 and y2 minus y1 will get cancelled. Then the equation that I am going to get further is q square by g is equals to, you send this denominator to the other side, y1 y2 into y1 plus y2 by 2. y1 y2 into y1 plus y2 by 2. See, this is when the specific forces are seen, where y1 and y2 are not give me a minute please. So now you see, so that's q square by g is equals to y1 y2 into y1 plus y2 by 2. Okay. So this relation, keep that in your mind. This is for the conjugate depths. And this q square by g, can I write as a yc cube? I can write this further as a yc cube is equals to y1 y2 into y1 plus y2 by 2. See, don't blindly remember this equation. Don't blindly remember this equation. See, these relations are for the conjugate depths, not for the alternate depths. Now let's see. We go back and we check with the one condition. So I hope you understood this. Q square by g is equals to y1 y2 into y1 plus y2 by 2. Now let's go back with the alternatives. Now you see here, this is an alternate depth, and what is the type of channel I am taking? Rectangle. And what is the equation I got? Q square by g is equals to 2y1 square y2 square by y1 plus y2. where y1 and y2 are alternate depths, and yc cube is equals to, means q square by g is nothing but yc cube, right? 2y1 square y2 square by y1 plus y2. Whereas this is for whom? Conjugate depths. y1 y2 into y1 plus y2 by 2. This is for the conjugate depths. Alternate depths 2 y1 square y2 square by y1 plus y2. Conjugate depths y1 y2 into y1 plus y2 by 2, and the LH is going to be same, q square by g or yc cube. Okay. So from this equation is valid for whom? Only for rectangle. This is only for the rectangle, not for any other channel. Sir, in examination, if they would have given for the triangle, then what we do, sir? Then again, you go with the basic. Don't apply this one. You go with the basic. What is the basic? F1 is equals to F2. F1 is equals to F2. In the case of the triangle, what is area? M by square. In the case of the triangle, what is area? M by square. What is z bar? Y by 3. You substitute, you can find this. So I hope you understood. It's irritating sound, sir. Okay, sir. That sound, that's, see, I am also in home only. Okay. So they have to prepare, right? In home, people cannot shut down everything for one of my work. So I have asked. That's a whistle. I'm sorry for that. Please bear that. Some sound, irritating sound. Sir, some sound is coming from behind. Please stop that. Please stop that. Okay, fine. So yeah, this equation is not for the alternate depth. This is for the conjugate depth, and this is going to be similar to that equation. So don't get confused. The similarities between the specific energy and specific force are very high. So that's why I'm comparing those things, and I want you to understand these things. Okay. Now further, see, this is not the end. What is my application? What is my application? To dissipate the energy. I need to find out that head loss, means energy loss. So for that, see, once I know this one, I can find out the conjugate depth. I can find out the conjugate depth. So if I know the YC and if I know the one of the pre-jump depth, I can find out the conjugate depth. So I'll go with the one more relation over here. Now, the next one is the relation between conjugate depths and Froude number. Conjugate depths and Froude number. So from the relation, from this relation only, you see, observe. So what is this relation? Q square by G is equals to Y1 Y2 into Y1 plus Y2 by 2. Okay. Y1 plus Y2 by 2. Now, divide with Y1 cube on both sides. Divide with Y1 cube on both sides. If you divide with the Y1 cube on both sides, then Q squared by G Y1 cube is equals to, you send this to this other side, 2Q squared by G Y1 cube. Then Y1 Y2 into Y1 plus Y2 by Y1 cube. Okay. So now you see, what is the Froude number, my dear? Froude number for the rectangle, it is going to be V by root Gy. This is for rectangle, right? I am telling you only for rectangle. I am not saying for any other channel. Then Fr square, and you know that V is equals to Q by Y. Fr square means Q square by Gy cube. Q square by Gy cube. Yes or no? Fr square. So now, can I write this Q square by Gy cube? You see Q square by Gy1 cube, right? Then can I write this as 2 Fr1 square is equals to y1 by y1 cube. 1 by 1 will get cancelled. Now you send this to the inside. If you send this inside, y2 y1 by y1 square. y2 y1 by y1 square means again 1 by 1 will get cancelled, which means y2 by y1, which means y2 by y1 plus y2 into y2 square, y2 by y1 whole square. Yes or no? So now you can rewrite this equation as y2 by y1 whole square plus y2 by y1 minus 2fr1 square is equals to 0. Does this just looks like a quadratic equation? So the quadratic equation is the solutions are solution for quadratic equation are, you know that. So whatever the solution is, by solving, I can write by solving. You know what is the solution for the quadratic equation? Ax square plus bx plus c minus b plus or minus root of b square minus 4ac by 2a. Yes or no? So what is the root over here? What is the root? y2 by y1. X is equals to minus b, right? And you tell me what is a value here? The a value is 1, b value is 1, and c value is equals to minus 2fr1 square. Okay. So a value 1, ax square. Here x is nothing but y2 by y1. X is nothing but y2 by y1. Ax square. A value 1. So b value 1. First minus b means minus 1. Plus or minus. So I don't go with minus because if I take minus, the total value is minus. I'll go with plus root of b square. What is b value here? 1. B square, 1 square, 1 minus 4ac minus 4 into a 1, and what is c? Minus 2fr1 square. Minus of minus plus 4 into 2, 8 fr1 square by 2 into 1, 2. So what is the final answer? Minus 1 plus root of 1 plus 8 fr1 square by 2. This is the final answer. This is the final answer. So, sir, you may ask me, sir, why you have divided with y1 cube? Can I divide with y2 cube? Yes, you can do. You can do that. And whatever this y2 by y1, we call this thing as a sequent depth ratio. It is known as sequent depth ratio. So, what is y2 by y1? Sequent depth ratio. y2 by y1 is equals to minus 1 plus root of 1 plus 8 fr1 square by 2. Okay. So now here, if you observe, this is a sequent depth ratio. So if I divide with y2 cube, then the relation C, that's going to be exactly reverse. If it is going to be divided with the y2 cube, then what is going to be happen? y2 cube means q square by gy2 cube fr2 square. y2 cube means then it's going to be y1 by y2. So y1 by y2 is equals to minus 1 plus root of 1 plus 8 fr2 square by 2. 8 fr2 square by 2. You see, whatever the denominator is there, right? If it is y1, Froude number is going to be fr1. If it is y1, Froude number is going to be fr1. And if it is y2, denominator y2, Froude number is going to be fr2. But I use this sequent depth ratio only because we know the incoming flow means pre-jump. What is a pre-jump? The pre-jump depth is going to be y1. And we know the incoming flow Froude number fr1, which is going to be subcritical, which is going to be supercritical flow fr1 greater than 1. And based upon this, now we are going to say the type of jump also. We are going to say type of the jump also. Keep that in your mind. Now, once I know this y2 and y1, Yes. So once I know this y2 and y1, I can find out the height of the jump. I can find out the height of the jump. So once we know this, then we can find out the height of the jump. What is the height of the jump? Height of the jump means, the height of the jump. What is that? Y2 minus y1. And once you know height of the jump, you can find out the length of the jump. And now, what is the last thing that we need to require is the energy loss. This energy loss is very, 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 very important. So because before the jump, what is this? This is the energy. This is the energy E1. After the jump, what is the energy? So after the jump, this is the energy E2. So what is the loss? Energy loss E1 minus E2. So now, finally, energy loss. What is this energy loss? Delta E, or head loss, Delta E is nothing but E1 minus E2. E1 minus E2. E1 means Y1 plus V1 square by 2G minus Y2 plus V2 square by 2G. See, this is all for the rectangle channels only. All for the rectangle only. This is also for the rectangle only. And this is also for the rectangle only. I told you clearly in open channels, mostly the questions we get is for the rectangle only. Okay. So now I can write for rectangle V is equals to Q by Y. V is nothing but Q by Y. So now Y1 I can write Y1 minus Y2 plus V1 square by 2G. So V1 square by 2G means a Q square by 2G Y square. Yes. So Q square by 2G can be written as a 1 by Y1 square minus 1 by Y2 square. 1 by Y1 square minus 1 by Y2 square. So let's take it as equation number 1. And you know that Q square by G is nothing but Y1 Y2 into Y1 plus Y2 by 2. So now this is equation 2. From 1 and 2, you please solve from 1 and 2. If you substitute, then finally the delta E is equals to Y2 minus Y1 whole cube by 4 times of Y1 into Y2. See, you know, this is delta E, and now I'm not doing the total derivation. We don't require this total derivation. So you just substitute this Q square by G as this value. Now, if you do so, then you are going to end up the delta E value as Y2 minus Y1 by Y2 minus Y1 whole cube by 4 times of Y1 into Y2. So once we get the relation between the conjugate depths and its depth, flow rate or critical depth, then we can find out from one conjugate depth, I can give you the other conjugate depth. For example, if I say, if we are going to have a flow rate and a pre-jump depth. I know the flow rate Q, and I have a pre-jump depth. Can't I find out the post-jump depth? What is the post-jump depth? Y2. And once I know Y1 and Y2, I can find out height of jump is nothing but Y2 minus Y1. Length of jump is nothing but 6.1 times of the height of the jump. Okay. So I can find out the height of jump and I can find out the length of jump. Now, once I know Y1 and Y2, I can find out the head loss also. So this much amount of energy is going to be dissipated. So that's all with the analysis. So I have given a lot of analysis over here. First, I said what is meant by hydraulic jump and what is happening while doing so. So the energy losses. So due to that eddy loss, which principle I am using? Linear momentum principle. So what are the assumptions? From those, by applying the linear momentum principle, I got to know the specific force, and from this, I constructed the specific force curve, and from the specific force curve, I can say at a minimum specific force there is a critical flow, and for any specific force other than F minimum, there exist two depths known as conjugate depths, and that conjugate depths are nothing but the pre-jump depth and post-jump depth. And what are the applications of the hydraulic jump and relation between the conjugate depths? So we need to find out that relation. If you know y1, how to find out y2 for rectangle, and then we have got the relation between the Froude numbers and finally the head loss also. So now let's have a break. It's around 8:50. Let's have a small break, and after the break we'll be discussing about so how to solve the questions. I did not discuss any objective questions so far, right? Let's see how to solve the questions and what are the how you are going to define the type of flow, type of jump based upon the Froude number also. We'll solve some of the questions, some of the previous GATE and IES and practice questions after the break. Have a break and come by 9:05, 15 minutes. Now, so let's come to the next session. Yeah. So once we know the energy loss, we can find out the power loss also. We can find out the power loss during a jump. That power loss is equals to gamma W into whatever the discharge into delta E. So whatever the power loss is nothing but gamma W into Q discharge into delta E. See, these are some other terms. In examination, they will ask you energy loss or power loss or efficiency of jump, efficiency of jump. What is the efficiency of jump, sir? Change in energy by initial specific energy into 100. Change in energy by initial specific energy into 100. And so that's about the efficiency of the jump, whatever the change in energy, or you can call it as a relative loss. Efficiency means nothing but relative loss. How much energy is losing with respect to initial? That's nothing but the efficiency. Yes or no? So power loss and energy means efficiency of the jump. Now, based upon the equation you see here, based upon the equation of solving here, if you observe clearly, y2 by y1, y2 by y1. If y1 is going to be changes, then fr1 is also going to be changes or not? Yes or no? No. You see, if the inlet Froude number fr1 is more. See, what is mean by fr1? Fr1 means inlet Froude number. You know, before the jump, the flow is supercritical. After the jump, the flow is subcritical. Before the jump, the flow is supercritical. After the jump, the flow is subcritical. And before the jump, supercritical, Froude number greater than 1. So fr1 is greater than 1. The more the Froude number greater than 1 means the more the fr1, the more the difference between y1 and y2. The more the Froude number greater than 1, the more the difference between the conjugate depths y1 and y2. And the more the difference between y1 and y2, the more the height of jump, the more the length of jump, and the more the energy loss. So, in simple words, what I want to conclude over here is, if the inlet Froude number is more, if the inlet Froude number is going to be more, then the ratio of y1 and y2 is more. The ratio of y1 and y2 means y2 by y1 is more, which means the difference between y1 and y2 is going to be more. When the difference between y1 and y2 is going to be more, then the energy loss is going to be more. Then the energy loss is going to be more. So I can say in simple words, if the energy loss is going to be more, then the jump effect is going to be very higher. So the more the efficiency of the jump, the more the energy loss. So the strength of the jump is depends upon the inlet Froude number. So whatever the flow that is coming right here, whatever the flow that is coming, whatever the inlet Froude number, there must be one fr1 or not. So the strength of this jump depends upon the inlet Froude number, my dear. Based on inlet Froude number, based on inlet Froude number fr1. So you know that if fr1 increases, then y2 by y1 ratio also increases, then energy loss also increases. Then energy loss also increases. fr2 means outlet, means after the jump. fr2 means outlet. So this is a supercritical flow. Now, Based upon that, the range of the Froude number and type of gem. When the Froude number is less than 1.7, when the Froude number is less than 1.7, see, obviously, if I want to say the Froude number, supercritical flow, it should be Froude number greater than 1. Yes or no? And if that Froude number lies between, suppose I can say, 1 less than FR1 less than 1.7, which means Froude number greater than 1 and less than 1.7. That type of jump, we are going to call it as a angular jump. Angular jump. Okay. And if the Froude number is going to be lies between 1.7 to 2.5, we call it as a weak jump. See, the meaning of angular jump is, you can see there is a small rise in the jump. That's it. You cannot see any reverse flow also. You can see small changes are there. So some deviation would be there. That is known as an angular jump. And then when Froude number is 1.7 to 2.5, it is going to be weak jump. So the meaning of weak jump is it rises, but it won't create any oscillations. It rises, it won't create any oscillations. And then 2.5 less than FR1 less than 4.5. So when the Froude number is in between 2.5 to 4.5, then we call it as a oscillating jump. Then we call it as oscillating jump. 4.5 less than FR1 less than 9. So if the Froude number is going to be from 4.5 to 9, then we call it as a steady jump. We call it as steady jump. And if the Froude number is more than 9, we call it as a strong or choppy jump. Strong or choppy jump. Okay. So this is the jump that we used to prefer. So this is a preferable one. So if you want to create a steady jump, then what is the Froude number range? If you want to create the steady jump, what is the Froude number range? 4.5 to 9. See, this is all about the based upon type of jump, means the strength of the jump, how much energy is going to be dissipated. So if you can create a Froude number, initial flow, if the initial flow, whatever the, when you are rising the gate, right? See, everything depends upon this gate only. Everything this depends upon this gate, this opening of that gate. You please observe, whatever this gate, right? And over to this gate, we are going to send some discharge, right? Over to this gate, you are going to send some discharge. You may ask me a question, sir, how come I find out this discharge, sir? How come I find out this discharge? See, for that actually that we can be discussing in the flow measurements, but for the gate point of view, it is not there. So what I will do is, you see, if this is a sluice gate and whatever this is upstream water level, and this is going to be the water that falls over here. Yes or no? So now whatever the discharge passing over here, let's take it as a Q. Whatever the discharge passing over here, that's going to be the Q. And how to find out, sir, how much discharge is coming over the spillway, sir? This is nothing but spillway, right? This is nothing but a spillway. So how much discharge is coming from the spillway, sir? Now, if the head of water above the crest of the level is going to be H, if the head of water is going to be the H, so now that discharge is equals to 2/3 of CD into root 2G into L into H to the power of 3/2. See, this is how much discharge you are going to allow over the spillway, or whether you take means if you want to take the sluice gate also the same thing. How much discharge you are going to allow? How much discharge you are going to allow? So I can write this one. Yes. So now where CD is coefficient of discharge, where CD is the coefficient of discharge, and L is length of weir or dam, and H is head of water above weir crest. See, the meaning of crest means, see this point, whatever the topmost point of the structure, this is known as a crest, my dear. This is known as crest. So what is the H? H is nothing but head of water above the weir. Okay, so you need to know how much discharge you are going to send, and once you know the discharge, my dear, once you know the discharge, from that discharge, see, if I take this length is going to be 1, L is nothing but width of the weir. You can write this L is length of weir or width of the river or flow. So this L can be length of the river. See, this is a longitudinal section, right? This is a longitudinal section. In the plan view, whatever, this is nothing of the hydraulic structure or not in the plan view. So what is this? Either L means length of the weir or width of the river. So this is a river. The L is nothing but either length of the weir or width of the river. So these equations are how this equation came, that we will be discussing for ESC students, that we are going to discussing in the flow measurement devices. That's a separate topic. And for the gate people, you just need to know what is this formula. That's it. So because based upon this discharge only, the flow is going to be created as a hydraulic jump or not. So it's all about how much discharge you are going to release. And based upon this discharge, the Froude number depends. Because you know the Froude number is nothing but velocity by root of g into y in the case of the rectangle. So it depends upon the flow rate. So based upon the flow rate, keep that in your mind. Based upon the flow rate, the Froude number, inlet Froude number changes. When the inlet Froude number changes, the type of jump is going to be changes. Okay. So that's what I want to say. Now, let's see some of the questions based upon this. Okay. So what is mean by spillway, Baba? Okay, fine. Forget about this. The spillway means it's an opening. Whatever this opening is known as spillway, my dear. This opening is there or not? Whatever this opening, the opening is going to be the spillway opening. We call it as spillway. Spillway is an opening. Spillway is a opening in the weir or dam. Spillway is an opening in the weir or dam to allow the water from the upstream to the downstream. You require some opening or not? That is known as a spillway. So forget about that term. Anyways, you are going to see those terms in irrigation. I don't want to make you confused more. Okay. Now, let's see. Now, let's come to the some questions. So come to this question, please. This question. Yes. The discharge per meter width, the discharge per meter width at the foot of a spillway is a Q 10 meter cube per second. See, the meaning of a spillway is whatever the opening, my dear. What we call this shape is nothing but okay spillway, and whatever this opening is there, right? This is going to be this opening, we are going to call it as a spillway. Okay. Now you see, I am allowing some discharge, and already I have calculated whatever the formula I mentioned just now, right? Whatever the formula I mentioned just now, the Q is equals to 2/3 of CD into root 2G into L into H to the power of 3/2. So they have already mentioned that whatever the discharge per unit width I am sending you at the foot of the spillway, So Q is given as a 10 meter cube per second per meter width, right? So in this question, it should be per meter width. At a velocity V1 is 20 meter per second. So at the foot of the spillway, what is the velocity? The velocity of the flow V1 is 20 meters per second. A perfect free hydraulic jump will occur at the foot of the spillway. So now the hydraulic jump is going to be happen at the foot itself directly. The hydraulic jump is going to be happen at the foot itself. Then whatever at the foot of the spillway, this is going to be the initial depth y1. Now at the foot of spillway, when the tail water depth is approximately, now you see what is this tail water depth. This is a tail water depth y2. So in the given question, it is clearly mentioned, does the hydraulic jump is happening at the foot of the spillway or away from the foot of the spillway? At the foot of the spillway. Clearly mentioned, a perfect free hydraulic jump will occur at the foot of the spillway. So they mentioned that at the foot of the spillway. So whatever the inlet depth at the foot of spillway, that is going to be the pre-jump depth. So first of all, let's find out this y1. Let's find out this y1. You know that Q is nothing but V into 1. So V1 y1. So what is y1 then? N by 20, which is equals to 0.5 meters. So now I know 0.5. Then whatever the discharge per unit width means, that's going to be rectangular or not? So can you please tell me what is the relation between the conjugate depths and the discharge? Conjugate depth and the Q. You know that Q squared by G is equals to y1 y2 into y1 plus y2 by 2. So here in this question, they did not mention any channel shape. So I'll directly take it as a rectangle. Okay. So now from this, we know the discharge. Please find out the discharge. Discharge. So discharge is given as 10, right? 10 squared by G value 9.81, y1 0.5 into y2 into 0.5 plus y2 by 2. You send these entire values to the other side. So 10 square by 9.81 into 4. So if you take this total values 0.512 also that side, 40.77 is equals to 0.5 y2 plus y2 square. 0.5 y2 plus y2 square. So now from this I can write y2 is equals to what is y2? Y2, I can write this equation, right? y2 square plus 0.5 y2 minus 40.77 is equals to 0. This is a quadratic equation. What is the root of the quadratic equation? Minus b minus 0.5 plus root of b square minus 4ac. B square minus 4ac. What is the b square minus 4ac, please? So b square, the b square is going to be 0.5 square minus 4ac, which means 4 into 1 into 40.77 by 2. So please find out this. So if you find out the value is equals to 6.14 meters. See, this is one way. This is a one way. Okay. This is one way of finding the Y2. Relation between the conjugate depths and discharge. Remember when to use small q, when to use capital Q, because both are discharges. Have you got any crack? What is small q? Capital Q by B, right? They mention for meter width, right? For all the discussion, if you're asking these questions, then I don't know when to use small q, when to use capital Q. It's not a hard and soft rule, my dear. It's not somewhere you have to use capital Q, somewhere you have to use small q. What is small q? There is a relation between small q and capital Q. Small q is nothing but Q by B. Yes. So we can use this by means of the sequent depth ratio also, or the other method is by means of sequent depth ratio, y2 by y1 is equals to minus 1 plus root of 1 plus 8 fr1 square by 2. But what is fr1? fr1 is nothing but v1 by root g y1. Okay. So what I do is I don't find out the velocity because already velocity is given, right? Already velocity is given. So now what is y1? y1 is nothing but q by v1. So 10 by 20, which is going to be 0.5. Then what is fr1? Velocity 20 by root of 9.81 into 0.5. Find out the Froude number. So the Froude number is going to be 9.03. The Froude number is very, very large, right? It's going to be create a steady flow, or just more than that. It's going to be create a strong, strong jump. So now you substitute over here y2 by y1 as 0.5 is equals to minus 1 plus root of 1 plus 8 into 9.03 square by 2. Square into 8 plus 1. Yes. If you solve, you will be end up with the y2 value as 6.14 meters. Okay. So either way you can get the same value. Either way you can get the same value. So this is for whom the given is going to be the rectangle. They did not mention anything, right? So I am taking it as a rectangle. Okay. Now. So why are you neglecting the minus root in the quadratic equation? Will it give to y2 by y1 ratio? Arey papa, minus means already minus b. Plus or minus means if you take again the plus or minus, minus b minus, the total value is going to be negative. Are you want the ratio as a negative? See, we are dealing with the magnitudes, my dear. So you don't take it as a negative value. That negative roots are not going to be acceptable. So whatever it is, means if you want to go with the 1 or 2, it's up to you. Hydraulic jump has a tail or head, sir. See, this is the head, this is the tail. This is the head. What is the meaning of tail water depth? Tail means downstream, head means upstream. Tail, and this is head. The meaning of tail water is on the downstream side, my dear. So y2 should be less than y1. Who said that y2 is going to be less than y1? This is y1 and this is y2. Do you think the y2 is going to be less than y1? So what if the Froude number is going to be 4.5? Is it steady or oscillating? It is you cannot say whether it is steady or oscillating. So it's in between. There's a transition stage. There's a transition of steady to oscillating. See, the jump cannot suddenly change from steady to oscillating. It's going to be transit. And some transition would be there in between the steady and oscillating. Okay, so that's this question. Now Coming to the next question, question number 25. A hydraulic jump takes place in a triangular channel. See, this time they have given triangle. And what is the vertex angle? 90 degrees. If the vertex angle is 90 degrees, then what is the side slope? The side slope is equals to 1. So you are very well aware, when side slope is equals to 1, what is area? Y square. What is the hydraulic radius? Y by 2 root 2. Okay. So now, as shown in the figure, the discharge is 1 meter cube per second. That's it. They have directly mentioned that 1 meter cube per second discharge only. And what is the pre-jump depth? 0.5 meters. And what is the post-jump depth? What is the post-jump depth? See, this channel is a rectangular triangle. Triangle. Is it a rectangular section or non-rectangular section? Non-rectangular section. So, okay. So now you see in these type of questions, see this type of question will not be expected as ESC. This will be expected only as a gauge because it requires a lot of calculations. Okay. Now let's see. You know that Y1 and Y2 are conjugate depths. What is the meaning of conjugate depth? What is the meaning of conjugate depth? Specific forces are going to be seen. See, whatever this equation I have done, this equation, right? This equation is for the rectangle. See, can't you find out this without calculator? Without calculator, you cannot find out. So in ESE, these type of big calculations you don't expect. In ESE, they focus more towards the numericals as a little bit explanations and more over the conceptual questions. Okay. So now you see F1 is equals to F2, then Q square by GA1 A1 Z1 bar is equals to Q square by GA2 plus A2 Z2 bar. Q square by GA1 plus A1 Z1 bar is equals to Q square by GA2 plus A2 Z2 bar. Okay. Now, in the case of the triangle, when M is equals to 1, area is equals to Y square. And what about Z bar? Z bar is nothing but Y by 3 or not? Because you know that the centroid locates at a depth of Y by 3. Okay. Now, you substitute Q square by G Y1 square plus Y1 square into Y1 by 3 is equals to Q square by G Y2 square plus Y2 square into Y2 by 3. Now, substitute the values of Q square by G and all those things. Now, what is Q? 1 square by 9.81 into what is Y1 square? 0.5 square. Y1 square into Y1 cube, 0.5 cube by 3 is equals to 1 square by 9.81 into Y2 square plus Y2 cube by 3. Let's find out the LHS first. What is LHS? What is LHS? LHS is going to be 0.449. R simple word 0.45. And RHS is equals to 1 by 9.81. 0.102 102 by Y2 square plus 1 by 3 means 0.33. Yes, where is it? So 1 by 3 means 0.33. 1 by 3, 0.33 cube. 0.33 by 2 cube. So now if you resolve this, then it is going to be, if you send this equation to the other side, Y2 square, and it is going to be Y to the power of 5. 0.33 Y to the power of 5 minus 0.449 Y2 square plus 0.102 is equals to 0. Now, think and say, can you solve this by means of the calculator? Cannot be solved by means of virtual calculator. Cannot be solved by means of the virtual calculator. Cannot solve by virtual calculator. Sir, then what to do, sir? If I cannot solve by means of the virtual calculator, then what to do, sir? So just simply what I do is I'll find out by trial and error method only, by trial and error. Now again there is a logic while you are going for the trial and error. The logic is you go with the options. You go with the options clearly. In all the options, what is the y1? This is going to be 0.5 meter. What is y1? This is going to be 0.5 meter. Use your common sense and you need to eliminate one option first. By using your common sense, you need to eliminate option 1 first. So what is that, sir? First, what I do is I'll find out YC. In the case of the triangle, YC is nothing but 2q square by gm square whole to the power of 1 by 5. See, I don't know the value. So what I'm going to do is I'm going to eliminate the option. Yes, now let's see. 2q square by gm square whole to the power of 1 by 5. 2 into, what is the q? 9.81 into 1 square whole to the power of 1 by 5. Come on, tell me this. 2 by 9.81 whole to the power of 1 by 5. So the YC value is equals to 0.73 meters. The YC value is going to be 0.727, 0.73 meters, which means you know that obviously Y2 must be greater than YC. Y2 must be greater than YC. Keep that in your mind because after the jump, you see Y1 and Y2 are conjugate types. So one is a super, other one is sub. So already Y1 is 0.5, Y1 is 0.5. So it is going to be Y1 less than is YC and Y2 should be greater than YC or not. So what is YC? 0.73. Now go to the options. Can I eliminate option A? Can I eliminate the option A? So eliminate A 0.57. Eliminate 0.57. Okay. Now how many options are remaining? 3 options are remaining. Now, arrays are still 3 options are left over, sir. Then how come I solve this one, sir? Now, sir, whenever 3 options are left over, don't take minimum, don't take maximum. You take the middle value. You take the middle value. Why, sir? For example, let me say I take a maximum. Think, listen to this point. This is general aptitude, means numerical aptitude for you. If I take the maximum, see out of these 3, 0.91, 1.02, 1.57. 0.91, 1.02, 1.57. Okay. So out of these 3, which is larger value? 1.57. Now, if I do solve this from the larger value, see, I don't go with the equation also. I can directly go with the here itself. I don't want to go with this also. I will erase this also. I don't want to go. From here itself I can find. Yes. So now cannot solve by virtual calculator. Okay. Or okay, let's take this value only. Okay. So now I have 3 options. How many options are there? 3 options. Should I go for less, minimum, or maximum, or in between? So what if I go for the maximum, sir? For example, if I substitute this Y2 as 1.57, my dear. For example, if I substitute the Y2 as 1.57, okay. If I find out this LHS, if the LHS is equals to 0, if I got the LHS as 0, then the answer is going to be correct. Then Y2 is equal to 1.57. If the LHS is not going to be 0, as I take the maximum value, then what are the possibilities that I can get the LHS? What is RHS here? RHS is 0. RHS is 0. So what is LHS? If I substitute 1.57, that is the maximum value in the given options. Either I am going to get LHS as a 0 or negative. Yes or no? So if I get the Y2 value, it means if I substitute this, if I get LHS as 0, then okay, LHS and RHS both are 0, then Y2 is equals to 1.57. But if I substitute 1.57 and if I get negative value, what is the meaning of sorry, if I get a positive value, what is the meaning of that? I have taken y2 more than the sufficient, which means it's not 1.57. The y2 should be less than 1.57. The y2 should be less than 1.57. So y2 less than 1.57 means how many options are there again? 2 options. I'm giving you only one chance for you. Only one chance, you need to get down the answer. So now if I take 1.57, either the total value can be 0 or more than 0. If it is 0, answer is 1.57. More than 0 means then you have to reduce the values 0.91 and 1.02. 2 options are there. So I cannot go further. Sir, okay. Now, sir, now will I go with the 0.91, sir? If I go with the 0.91, for example, if I go with the 0.91, my dear, now if I go with the 0.91, what may be the possibilities that comes? So that is a minimum value. If you substitute, either you can get LHS as 0, or either you get LHS as 0, or as you take the minimum value, then LHS is going to be negative. Then LH is going to be negative. Yes or no? So now the y2 should be more than that value. Yes or no? Then how many options are there again? 1.02, 1.57. I have only one chance, so I lost it. So keep that in your mind. Now there comes the logic. Whenever they give the options, step number 1, eliminate one option. Eliminate one option. So I eliminated. And in the remaining 3, always you apply the trial and error with the middle value. Means out of the 3 values, the middle value is going to be how much? 1.02. Means middle means it's not average. Minimum, maximum and middle value would be there. 3 options. Minimum, maximum, middle. And you always use middle value. Now you see, by taking y2 is equals to 1.02. Then what is LHS? What is LHS? The LHS is equals to 0.33 into 1.02 equal to the power of 5 minus 0.449 into 1.02 whole square plus 0.102. 1.02 whole to the power of 5 into 0.33 minus 0.449 into 1.02 whole square plus 0.102. So this is going to be almost equals to 0 because these 2 values are going to be 0.102. This is going to be 0.1028. So 0.1028 minus 0 plus this is value minus value minus 0.102, which is going to be minus 0.0008, almost is equals to 0. Yes or no? So if you solve this, it is going to be almost is going to be 0. Value is going to be 0. Okay. So now what if I would have all this one, and if sir, if this value y2 is going to be some, let's say sir, I got -1, sir. Let's say the LHS value I got -1. I got -1 means I have substituted less value. If I get this LHS negative means minus very less value means some let's say -0.5 or -1. Okay, then what I substitute is 1.02 is less value. So I have to substitute more than 1.02. I have to substitute more than 1.02. And what is the answer then? 1.57. So when I substitute 1.02, if I would have got a positive value, LHS as positive, then I substituted more than enough. So the answer is going to be less than that 0.91. I hope you understood this. Can we expect this as a NAT in this type of questions? So no, this type of questions cannot be asked as NAT. You cannot get as a NAT. These type of questions can be asked. This type of questions can be asked as MCQ only, not MSQ also, not even MSQ. It's going to be asked MCQ only. It's not even MSQ. Okay. So that's all with the question. I hope you understood. So now let's see this question. Question number 26. A rectangular channel carrying a supercritical flow is provided with a hydraulic jump type of energy dissipator. So given is rectangular channel. Given is a rectangular channel. So the type of channel and the supercritical flow is provided in a hydraulic jump. If it is expected to dissipate 5 meters head of water in the formation of jump. It is expected to dissipate 5 meters head of water means what is the energy loss? 5 meters. And if the inlet Froude number, what is the inlet Froude number? FR1 is 8.5. The approximate sequent depths. So Y1 and Y2 both are there. Look, how many unknowns are there? 2 unknowns are there. If there are 2 unknowns, I require 2 equations, right? What are those 2 equations, sir? See, what is delta E? Y2 minus Y1 whole cube by 4 times of Y1 into Y2. Yes or no? So now I know delta E, but I don't know Y1 and Y2. So what I do is, if I know the FR1, can I use the sequent depth ratio? Y2 by Y1 is nothing but minus 1 plus root of 1 plus 8 FR1 square by 2. Minus 1 plus root of 1 plus 8 into FR1, 8.5 square by 2. So now from this, 8 into 8.5 square plus 1 square root minus 1 by 2. So whatever this ratio is going to be 11.53. Whatever the Y2 by Y1 is equals to 11.5. So now from this, can we write Y2 is equals to 11.53 times of Y1? Yes. Now you please substitute this in the delta E. If I do substitute, say I have 2 equations, right? This is equation number 1 and this is equation number 2. 2 unknowns, 2 equations. Now can I write delta E is equals to Y2? 11.53 Y1 minus Y1 whole cube by 4 times of Y1 into Y2. What is Y2? 11.53 Y1 is equals to 5 meters. Okay. Is equals to 5 meters. Now, you please find out the Y2 value. See, 11.53 minus 11.53 Y1 minus Y1. 10.53. 10.53 Y1 cube by 4 into 11.53 into Y1 square is equals to 5. Okay. So now in this you can write 10.53 to the power of 3 by 4 into 11.53. So which is going to be 25.32 Y1 is equals to 5. Means Y1 square, Y1 cube. And what is Y1? The Y1 is 0.197. What is the Y1 here? 0.197. The nearest value is going to be how much? 0.2 meters are there here. So the nearest value 0.197 means 0.2. And once you know that Y1, then what is Y2? Y2 is nothing but 11.53 into Y1 0.197. Which is going to be 2.27. So approximately this is going to be 2.3. Now you go to the answers. Options are 0.2 and 2.3 meters. So this is 0.2 meters and this is going to be 2.3 meters. Okay. So rounded to one decimal. That's all. So we know how to use the conjugate depths, how to determine the conjugate depths by means of the see. This is the for non-rectangular sections. I went with the basic and I have done by means of the trial and error approach. If it is going to be a rectangle, then I can use the relation between conjugate depths and the Q. I can use the sequent depth ratio, and then so how to utilize the energy loss, and from this how to determine the conjugate depths. Okay. I hope you understood these concepts. So that's all with the and remaining only 2 questions are left over. So now these are for the classroom practice questions. Now for the question number 28, you see, in the case of the question number 28, in question number 28, sudden closure of a sluice gate. Sudden closure of a sluice gate. So A, sudden closure of a sluice gate. If you suddenly close the sluice gate, see, sudden operation of the gates causes the unsteady flow. Sudden operation of the gates causes the unsteady flow. You know that unsteady flow means sudden operation of gates. I told you this point in the starting. If you operate the gates gradually, steady flow, and suddenly unsteady flow. For the sudden closure, then this is going to be unsteady flow. Hydraulic jump, just now we have discussed the hydraulic jump. Hydraulic jump is nothing but rapidly varied flow, right? 2. Spreading of irrigation water in a field. Spreading of irrigation water is nothing but spatially varied flow. So I discussed this point in the starting. What is meant by spatially varied flow? If you add some water or extract some water from the system, that is going to be the spatially varied flow. For the spatially varied flow, this is going to be 4. And flow in main irrigation canal, that's going to be uniform flow. I have given all these examples. What is the uniform? Where do you see uniform flow mostly? In irrigation canals. And whatever the spreading of irrigation water or runoff, that is spatially varied flow. If you suddenly close the gates or suddenly open the gates, that is unsteady flow. What is the answer? 3241. Option is going to be B. The only one question left over, 28 questions total. One question left over. This is based upon the surge that we are going to discuss tomorrow. So now there are some previous gate and IS questions are there, but as I have one more class after this, I have to solve now. Now today I am giving you homework. This is GATE 2019 set 2 question, my dear. GATE 2019 set 2 question. I am giving you this as a homework for you. I'm giving you this as a homework. So you please go through this question and you solve. You have to solve. And I'll tell you what is the logic over here tomorrow. Okay. So if you can understand this and if you are going to be apply your concepts literally well, then you are going to solve this. Otherwise, you cannot solve that one. So what is the one point that we need to understand after this? You know that after the hydraulic jump, what happens? Once the jump is going to be formed, yeah. Once the jump is going to be formed, what is going to be happen? There is uniform flow, and once the jump form from here onwards, the flow is going to be uniform. The meaning of uniform means normal depth or not? Yes. So this is one logic that you need to apply over here. After the jump, the flow is going to be uniform. Okay, and that point we'll be discussing tomorrow. And I'm giving you this question as a homework question for you. Here's a homework. You please try to solve this for the next class, and I'll be discussing the remaining things in the next class. So that's all for today's. And if you have any doubt, so now today I'm not going to take any doubt clearing session. Our surge is there, and later on dimension analysis is there. Okay, So for the dimension analysis and also there. So tomorrow we are going to complete the open channel flow. Tomorrow we are going to complete the open channel flow, and then the next following 2 days we are going to discuss about the dimensional analysis. So by tomorrow we are going to complete open channel flow, and then we'll start a dimensional analysis. Okay, fine. So that's all for today. Please have a look, and I'll be attaching the PDF. Yes. That's it for today, and I will meet in tomorrow's class. Till then, have a good day.